Today, I would like to speak a little bit about data labeling on a large scale, which is turning into a must-have expertise of modern specialists in machine learning. My name is Olga. I am the head of Taloka crowdsourcing platform, and in general, at Yandex, I am in charge of providing all the products of Yandex with the necessary training data, human labeled training data for all machine learning products of Yandex and for implementation of crowdsourcing in different parts of business processes. And here are 3 ideas I would like you to learn from this lecture. First one is that in Kaggle, you compete within a given data set, and usually nobody cares about where this data set comes from. Everybody cares only about the quality of the algorithms. But in real world, actually in the industry, you compete within the whole pipeline of production of machine learning. And those who know how to manage the data labeling effectively eventually win in the overall competition of products and companies in the modern AI industry. The second idea is that in the same way as you would not want to outsource your expertise in machine learning in a company, now every technological company tries to raise their own center of expertise in machine learning rather than to outsource it somewhere. In the same way, you would not want to outsource the expertise in data labeling, and hopefully I will manage to show that now data labeling becomes one of the key processes and key parts of the machine learning production, which needs to be a part of the core expertise of the team. And the third one is that hopefully I will manage to show that data labeling on a large scale is actually a purely engineering task. When you deal with the crowd is with yet another computing cluster and create some automated pipelines for managing it. Actually, whichever sphere of AI applications you take, whether it is search or voice assistance or e-commerce or whatever it is, the irony of the modern world is that the majority of AI solutions requires some data labeled by human. Actually, the more AI is developing and the more it goes further offline to new spheres of applications, the more human labeled data it actually requires. This is kind of a strange fact about artificial intelligence, to how a great extent does it depend on actually human intelligence and human labeling. If we look at the modern AI industry, we can see that it actually stands on 3 pillars. These are algorithms, hardware, and training data. And while the first 2 have already become commodities, everybody is using the same libraries, engineers are moving from one company to another and sharing expertise, everybody is using the same clouds, etc. The data is still a bottleneck for many applications of AI. And actually, the one who knows how to build up scalable pipelines for data labeling gets a very huge advantage in the business in general. I like to illustrate it on the example which is very close to us, because I personally started at the search team at Yandex, and because Yandex itself is initially a search company. So this is the pipeline with which we are dealing with it for the last 10 years. But in general, the example is quite universal. This is a common approach, whichever sphere of machine learning application you take. Is the production of the new ranking formulas pipeline. How does it look like? You have some pool of training data. You have some production formula which is shown and used by the current production algorithm and shown to the users. And you have a team of engineers who are constantly working on new versions and creating new algorithms. So they are developing new and new versions of the algorithm. And what happens next? First of all, you would need constantly to evaluate the quality of your production and to know how it actually works. Secondly, you need to evaluate the quality of those new formulas which have been developed by your engineering team. And before being ready to send those new ranking formulas to A/B testing on real users, so-called online experiments, you would need to make sure that this is not a fully trash, and you need to somehow evaluate its quality in the offline. When people look at the results of the search, look at the search results, evaluate their relevance to certain search queries, and their evaluations then are aggregated and some metrics of the quality of the search are computed. This is what is called offline evaluation. Then we somehow compare the quality of new versions or new formulas, comparing with the production one, and those who are not totally worse than the production are sent to A/B testing, to online evaluation. And the version which constantly outperforms the current production, both in terms of offline and online evaluation, becomes a new production one. And the turn goes on and on in the same way for many, many years. And this is a constantly developing process of constant development of the quality of the algorithms. And here we can see that in which parts we actually would need human labeled data. We need some human labeled data to collect the training pool. We need some human to evaluate the quality of the ranking formulas, both for production and for the new versions of the algorithms. And even if we simply calculate the number of points here, we can see that almost half of the whole pipeline of creating a new AI product depend on the human labeling. And actually, those estimations vary. Some of the sources, for example, recently I have heard somebody from Tesla said that like 80% of their production is actually dependent on human labeling. So the estimations vary, but the point is obvious. A large percentage of the whole pipeline of creating new AI product depends on human labeling. And the second idea which can be seen from this scheme is that actually there are two quite simple or quite straightforward ways to improve the quality of an AI product. First of all is increasing the set of training data and updating it with a more up-to-date and relevant data. And the second one is faster validation and implementations of new models. And if you, for example, if your competitors are not restricted with these things, and they can increase the volumes of the training sets, and they can evaluate and implement as many models within a short time as they can, without having a bottleneck in human labeling, they get a huge advantage. For example, if you cannot do this, you would be in a problem. So this means that actually setting up a scalable data labeling pipelines is now one of the crucial parts of AI production. So what should we do to actually be able to achieve this and not to have data labeling as a bottleneck? And our experience of more than 10 years working with the data labeling for the needs of Yandex shows us the following answer. First of all, we are sure that the quality of the business process should depend not on the particular skill of a particular performer, like so-called expert approach, but rather it should depend on the quality of the business process. Because when you a very traditional approach, which I guess everybody starts with when they need some data labeling in order to start training some formulas, is that you take one or two or a dozen of some highly trusted experts, and they do some labels, and everything works fine until you need to scale this, and then it becomes a huge problem. And the alternative approach, which we use in Taloka, is that we take the process, we decompose it into several steps, we add the quality control to each step of the process, we automate some sub parts of the process where possible, and then we make the process like resistant to the mistakes of single performers, and performers can be easily replaced with one to another, and the process can be easily scaled up when you need to scale up your production. In general, this is what we call a crowdsourcing approach, a specific way to design a business process. When you take a huge task, some high-level task, you decompose it into sets of very small and minor tasks. Each one of them requires minimal effort from a person. And then you send this task to a cloud of independent performers. Every single performer makes the smallest effort, but then their efforts taken together are aggregated and resulted into the solution of your initial high-level task. I would give you some examples of applications of that approach in some AI products. For example, the self-driving cars, you most probably know that in order to effectively navigate on the streets of the cities, self-driving cars require effective computer vision models. And in order to train these models to recognize objects on the streets, you need to feed them with large amounts of such segmented pictures with every object on them highlighted with the polygons. And there is a large part of the whole highly technological production of the self-driving cars is to how to actually set up this process of marking up those millions of images. So how does it look like? For example, our final result is that we have millions of pictures with all objects on them highlighted with polygons, just like it was shown on the previous image. And we decompose this task into several steps and several subtasks, each of which is very simple. So the first task would be mark up every object with the categories, like this is the road, this is a car, this is a pedestrian, etc. Then the task is decomposed depending to each category of the object. And then so we verify whether this categorization of the objects was correct or not. And then we decompose the task according to every single object. And so, for example, the task is please mark up all the pedestrians on the street. And one person marks up all the pedestrians on the street. Then we show this task to a group of people at the same time, asking them, please look, here are all pedestrians highlighted, if there are any mistakes. If they vote that everything is correctly, then we move forward to the final result. If they say, okay, there is one pedestrian missing or something like that, we have a next step with people asked to additionally highlight the missing object or something like that. And this task in turns is verified once again by a group of people. And thus it is repeated until every object of every type is highlighted. Or another example is, for example, generation of content. For example, for the voice assistant, in order to train your voice assistant to activate anytime they call an activation word, like probably you know, Yandex has Alisa, and whenever you say Alisa, she wakes up saying, hello, I'm here to help you. So how did we manage to collect enough for those activation words to train her understand her calling effectively? Once again, it can be done quite easily using the crowdsourcing. There is a simple task for every single person. Please say, "Hey, Alisa." Then there is another verification task when we ask several people to listen to this recorded phrase and say whether it was done correctly, or if there was too much noise on the background, or if the phrase was irrelevant or anything like that. And thus it is rejected if something was wrong. It is accepted if everything was right. And this allows us to collect many thousands or millions of records in parallel, and thus collect the huge training sets within a really short time. So, for example, here is the real life example, like 400 phrases to be collected within 10 minutes and several dollars in total budget. Another example is the audio transcribition. It's a vice versa task when you have some audio recording and you need to turn it into the text. It is a more difficult task, so at first we need to train and select some performers who would learn, because there are many nuances, like how to deal with background noises, how to transcribe foreign words and something like that. So people need to learn those small nuances, and you need to train them. After you have trained them, the task is also decomposed into several tasks. There is a short phrase to be transcribed, and you ask one person, then you ask another person, and yet another person, until you get k exact matches of their texts which they had transcribed, and you repeat actually until you collect k exact matches. And this is how you collect the needed number of audio transcriptions. And it also, like, for example, took 2 hours and $10 to collect transcription of 3,000 short phrases. I think one of the last examples here in my set, I like it because it's a little bit irrelevant to machine learning, but just shows the wideness of abilities of the crowdsourcing, how you can also use it in different way. For example, also speaking about Alisa, Alisa is famous for its strong character, and she has certain sense of humor, and sometimes she likes to tell jokes, and we see that people like to just chat with her. And of course, as a product, Alisa needs to have a large set of and large database of jokes, not to be boring and not to repeat the jokes again and again. So there was built a production of the jokes for Alisa. There is a team of professional copywriters who write those jokes. But because this is, once again, a production and industrial process, and they write those jokes in dozens, one needs to control somehow the quality of those jokes which are produced on such a large scale. That's why their jokes are sent to Taloka to a specific task which is called side by side. It is actually an interesting approach when it is difficult to get some formal evaluation of the object. But for some subjective cases, it is much easier to show a person 2 objects and ask him or her to compare which one do you like more. And it works pretty well with the jokes also. So the jokes are divided into random pairs and sent to talkers, and they vote for the best jokes. And then you get a ranking of the best jokes. And that's how you can actually select the best jokes, and also keep an eye on the copywriters who constantly fail to provide the best jokes. And this is just an example of how it can be done. Like within 30 minutes, you can evaluate 150 jokes, each one evaluated by 20 talkers, something like that. So how it actually works and what infrastructure lays behind those applications and what makes it possible to create such a pipelines. So in general, this is our open crowdsourcing platform where anybody can register as a performer. We call them talkers, or as a requester. Any company or any individual researcher or whoever, they post their tasks on the platform, and talkers are free to choose their tasks if they like them. Taloka is a Swiss company. Our team is distributed between Switzerland, US, Belarus, and Russia. And we, during our history, we have started, as I have already mentioned, as being a small team of infrastructure for the search. Then we have grown to become an infrastructure for the whole Yandex, and now you can take any product of Yandex, you scratch it, and you'll find some processes run on Taloka inside it. And our ambition right now is to become a worldwide infrastructure for the whole AI industry. We already are used by many very widely known technological companies, and we see the constantly growing interest towards the crowdsourcing and the opportunities of data labeling at a large scale using Taloka. So far, we have been growing quite fast. We have launched Taloka, I think these days would be the exactly 6 years since we launched it. It was somewhere in the end of November 2014. And since that, we have been growing both in number of active projects. You can see it on the left chart, and as well as in the number of active users or performers or talkers who are participating in our tasks. Like previous year, we have ended with more than 2 million people who actually participated in fulfilling the tasks and earning some money on the platform. And this year, we expect these numbers to overcome 6 million people. These are the data forecast based on the first 6 months of our development in 2020. And while setting up the processes on the crowdsourcing platform, one needs to answer several major questions, like how to make these processes scalable, how to provide good quality, and how to stay within reasonable budgets. Because whenever you do something on a large scale and you need to, I don't know, evaluate 1 million of images, even if every single piece of work is quite cheap, if you multiply it by 1 million, it becomes quite a huge budget. So one needs to keep it in mind all the time. And now I would like to say a few words about how it actually works and what mechanics lay underneath those answering those questions. So first of all, it's about scalability. Actually, it's quite even, I don't know, a pity for me. What I see, especially the more we go abroad and the more we deal with some international companies, the more we see how widely it is spread, and it is so sad that data labeling for many companies and in many cases is still organized in a style like it has been used to in the 20th century, when people are kept in some very, very tiny and low quality offices. They are forced to do some routine tasks without no ability to choose tasks, with no ability to make breaks. And you probably have heard of these scandals and problems with, for example, moderators of some social media who are forced to watch some cruel videos for 8 hours a day, and they really go crazy after that. And this is a very, I don't know, unhuman approach towards the performers. And also during the pandemics, it has risen a new problem because, for example, in some high technological companies, many engineers have been sent to work from home, but unfortunately, many moderators and data labelers were still kept in those tiny offices, having to risk their health. And this is a huge ethical problem that is now being discussed about this industry. And we believe that it in all the ways it should be different. We believe that the main ideology of the platform like Taloka is that the complete flexibility and freedom for the performers to choose from hundreds of available tasks, to come and go whenever they want, with no requirements in regularity, with no requirements in constantly being attached to a specific task. Any performer can come and go, can spend 10 minutes on a platform or 2 hours, can come and go, come back the next day, every day, or once a month, or even once a year. It actually doesn't matter, because even the smallest effort then is being automatically preceded, and we know how to get a useful signal even out of minor and irregular efforts of those random people. Right now on Taloka, we have more than 8 million registered performers from different countries. They speak different languages, and the platform is available both on desktop and on mobile applications for iOS and Android. We have started, of course, to provide data by Russian-speaking performers, Talokers, but recently we have started our expansion to the whole world, and right now we have many performers from Asia, from Africa, from South America, from North America, from Europe. You can see this is a current top of countries from where we have active Talokers. But this is quite a dynamic situation, because we just have a list of 190 countries, and we acquire more and more Talokers in every country. So we expect soon to cover like the whole world with Talokers and with tasks available for them. And actually dealing with the crowd has a certain number of fundamental advantages. First of all, this is about the process, which is run 24 hours, 7 days a week, because when you have those global workforce and so many people ready to perform your tasks, at every moment of time there is somebody who would be actually performing it. So this is an ongoing process. Very important thing is that you can get in touch with the wisdom of millions of people, and their collective expertise is actually colossal. And whenever you need to find a person with a specific expertise out of 8 million people, you can be pretty sure that you will find somebody with this needed sphere of expertise. The fact that there are different regions and they speak different languages, they use different devices, opens a wide variety of options, for example, for quality assurance testing, like to test how some software works in different regions on different devices, and etc. And lastly, this is an on-demand scaling, meaning that it is very easy to scale your process. Just you add more tasks and there are more people ready to perform it. But when your task is over and you have collected the needed amount of data, it's not a problem. You just turn your process off and people just switch from your project to another project. So another requester, there is no problem for people, because they have so many tasks to choose from. And in general, we are using the same universal scheme for scaling the processes. On top of this there is always a high-level manager who actually is the main person in this pyramid, because he or she is the one who actually designs this effective pipeline and designs all the processes of the quality control and training and etc. Then there would be some experts who provide benchmark labels and some training and guidelines, instructions for the crowd. Then there is the crowd, which actually provides, basing on these guidelines and basing on these benchmark labels, they provide the whole majority of data labeling. And sometimes when it is applicable, use some machine learning based classifiers, and all for automated markup is also used. In general, this approach works when, firstly, on the platform side, there are effective tools for quality control, and we'll speak about them soon. And secondly, when the requester actually has the needed expertise and knows how to build smart pipelines resistant to mistakes of single performer. And we will talk a little bit about that too. So when we speak about the quality, there is actually quite a standard set of tools for managing the crowd, which you can be sure that once you have done those 6 parts, you can be sure that as the outcome, you will get the good quality. This has been proved by the, thousands of use cases so far. So first you need to decompose the task into as simple tasks as possible. Secondly, you need to select and train the performers in order to make sure that they know how to follow your specific nuances and some specific requirements of your particular tasks. Then you set up tools for the quality control. Then you apply some motivation and monetary motivation in order to motivate people try harder and also to pay more to those who actually show better quality. And then you apply some mathematical methods for aggregating the raw results from various talkers in order to get the final verdict, which would be most probably ground truth. So there are quite standard approaches towards the quality control. There are the honeypots. We call them the honeypots. So these are the tasks for which you know the correct answer, and you inject those tasks into your data set. And by observing automatically how the person answers on the honeypots, you can extrapolate and estimate the person's quality on the whole data set. And then it is important and fundamental tool for monitoring the agreement level and the consistency between different performers. Most often the same task is sent to several performers and we observe how do they agree with each other. Then, as I said, there are tools for training and pre-selection and giving access to your production tasks only to those people who have passed some training sets and passed successfully your examinations. Then for more difficult tasks, there can be used some post-verification when one person is doing a complicated task and then a group of people verifies whether the task has been done correctly or not. They in turn are being checked by honeypots and the agreement level. And this is how you can control the quality in more complicated tasks, such as, for example, image segmentation for the self-driving, as we have shown before. And also some dynamic pricing, depending on the quality. When the better the quality is, the higher the performer is being paid. So there are some general approaches towards the training. They actually are quite similar to the approach of the machine learning in general. When you have a set of like a training set, a set of examples which you show to a person, and while watching these examples, a person trains their internal neural network to understand the logic of your task. And then you show them the exam like a validation pool where they show how well did they actually understand the specifics of your tasks. And only those who have passed the exam successfully are given access to your production tasks. The aggregation of the results is the sphere in which I would say the majority of scientific research is being proceeded. It's quite a classical task when you have, for example, 3 people answering the same question, and like, what if they all agree, or what if 2 out of 3 give one answer and the third person gives another answer, whether we should simply rely on the majority vote, or whether we should somehow weight the expertise of every particular performer, because in some cases the one who disagrees with the majority is not wrong. He or she disagrees because he or she is an expert and the majority is not an expert in this topic. So there are a majority of different mathematical models approaching this problem and trying to find the optimal solution. Actually, the simple majority vote is not that bad, and it can be used very effectively in majority of cases. But in some cases, more sophisticated methods allow to increase the quality quite significantly on the same data set. And such tools are implemented in the platform already, so you can use them. So as I have said already, once you have set those parts and decomposed the task, provided the training for your performers, set up effective quality control and aggregated the results, you can actually be sure that you can get the good quality for your initial task. And finally, speaking about the pricing, I can show you some real life cases of how much would it cost and how much time would it take to collect some certain data sets, like 1,000 of side-by-side comparisons within 10 minutes, or some object segmentations or audio transcribition. So you can see here the actual numbers. It is important to understand that for the majority of the performers, Taloka is a source of additional income, which they are free to earn at any time when they have some spare minutes. And effectively, this is one of the only services for reliable instant income in the internet. There are so many options for earning money on the internet, but so few of them are actually reliable and really worth spending time on. And what is important is because the performers on Taloka are not forced to perform tasks regularly, it means that it attracts people from different backgrounds and different professions with different motivation. There are not only those who are here to earn money because they are in need of money. There are also people who are there because they are interested in the sphere of machine learning and they want to feel how it actually works from inside. There are people who just like specific types of tasks and they come only when they see their favorite tasks appearing, and etc. In general, the pricing is set by a pure marketplace balance, so every requester is free to set any price they want. And then it is balanced by the demand and supply, and the more difficult the task is, or the more specific requirements towards the talkers there are, the higher would be the price. One of the approaches which can be used to balance, to optimally balance pricing within a fixed budget is what we call the incremental relabeling. And the idea is actually quite simple. When we at every step, we forecast and estimate how many people with the given level of quality would we need to achieve the expected and needed level of confidence of the answer. And usually you would need a lot of unreliable people to answer the same question consistently. Or you would need a very few people with high level of trustworthiness to obtain the same level of confidence in their answer. And thus you can share the same budget either between a large group of unknown and untrustworthy performers, or between a small group of very highly trusted people. And that's how you can balance your budget in the same way, motivating those who perform with higher quality to get higher paid. In general, everything that I'm speaking about is hopefully showing you that the data labeling on the large scale is nothing about the people management, but rather it's a purely engineering and mathematical task when you have millions of people, each of whom are not forced to do anything regularly. Actually, the only requirement to talkers is being human. This is what we track very carefully using our anti-fraud mechanisms. But other than that, we do not require anything. At the same time, requesters who deal with the crowd as with yet another computing cluster, and using the API create some automated pipelines of production of data labeling using the crowd. And what we see actually that the expertise of working with the crowd, it becomes one of the key competencies for any serious technological company who is building their AI production. And what we see both on the experience of Yandex and also on the experience of other requesters in Taloka is that the demand for people who know how to deal effectively with the crowd is just increasing. We have, we see that the people who are working in kind of this new profession should have a certain, actually they are not restricted to have any specific background. It is not a purely very technical profession or something like that. But usually such a person needs to have some basic technical background and be technically literal, and you know the basics of statistics and machine learning, but also should feel the empathy towards the performers and have a very good skill of understanding the real needs of the business and being able to design a complex business process. And we have called this new profession a crowd solutions architect because this is a person who is able to solve practically any task or any problem using the crowd. And we are now developing a set of materials which would help people who are interested in this profession and in this specialty to learn and to become the CSA. For example, at Yandex now, several dozens of people work on such specialization. And also several dozens of people, as far as we know, work on the same tasks in different companies all over the world with who are dealing with, at least with Taloka as a crowdsourcing platform. First of all, you can visit the website taloka.ai to learn about what we call the crowd science and some materials about that there. Also, our team is arranging crowd science trainings and tutorials for teams and companies and collectives. So if some of you would be interested in that, you can apply, and we would be happy to invite you to some of our such events. Also, we are conducting tutorials we are trying to conduct them on all the major data science and machine learning conferences. Like recently we have had tutorials on KDD and previously in June CVPR, and we would be attending some of the conferences in 2021, so you can keep an eye on and meet us on some of the major international conferences. Soon there will be new RIPS. I don't know if somebody of you are visiting it. If you do, please welcome to our workshop. It is organized by the Taloka team, and it would be devoted to the modern problems of the crowdsourcing and the questions of both effectiveness of its usage and ethics of the whole data labeling industry. Also, I was asked to tell you that if you are interested in actually trying Taloka, or if you are in need of collecting some data sets, you can use our promo code. Here is the guideline. You can fill in the form, and if you register and fill up with some money, you would get additional bonus on your account, which you can effectively use to collect some data which you are in need of. I guess that's all from my side. Thank you very much. I would be happy to answer the questions if there are any. There are some questions. I would read them, right? Would be great to be able to build such pipelines from blocks, label, review, if good, give, if bad. As I know, currently we should manually create several tasks one by one for labeling, review, and so on. This is the question from Ivan. This is partly true. Right now, you can only manage that using the API, and manually it is not very convenient, and our product team is working on making like those blocks structure actually available. Right now it is available for internal use of Yandex, but we are making it available for all the requesters. I hope you will be able to use it in some future quite soon. Is there a template pipelines for well-known tasks? Are the labeling entirely done by performers, or there is a human in the loop training models helping? Answering the first questions, there are some template pipelines described in our materials for certain well-known tasks, but not yet for all of them, but we're working on that. This is a really good request, which we hopefully will perform soon. Regarding the second part, right now, Taloka itself is a purely human data labeling platform, but it can be effectively synchronized with some automated processes using the API. Natalia has sent some materials to the chat. Thank you very much. Some questions from the YouTube. It seems like the following effect takes place. When you simplify the task for the data creators, it causes them to take it less seriously, so the data quality goes down. How do you handle a problem like this? I would not agree with that. I actually would need to find, but I definitely remember that we've read some scientific articles about that, and we also see it on our own experience of the past 10 years of building those difficult and simple pipelines for the data labeling. Actually, the effect is contrary. When you simplify the task, it is easier to explain for a person what actually to do. Secondly, it is easier for you to control the quality of this part. And thirdly, it is like you decrease the entrance level, so you have more people capable for performing this simple task. Thus, it increases the number of people, increases the speed of performance, and decreases the pricing. When you make a very complicated task and expect a person to take it seriously, this is a classical, what I call the expert approach. When, yes, you can do it on a very small scale. You can have one or two or a dozen of experts. They will take every single task of you very seriously. But when you need to scale it at least 2 times or 10 times, you are in the big problem. You would just find it difficult to find another expert who would take the task in the same way seriously. If you don't have the quality control, you will find that actually it is impossible to synchronize those 2 experts. Each of them would be very serious about how they take the problem, but you would see that they can actually think in different directions. And if the process is not formalized, it would be a problem. So to make it short, again, like all of my experience and everything says that there is no such problem. The problem is more psychological for the requester to actually understand that once you simplify the process, you're actually making it better. Okay, but thanks. It's a very interesting question. One can attempt to automate the data creation process using generative ML models and transform the task of generating to the task of rating the generated data. This is true. This is one of the approaches, and it is implemented by some of the requesters. Sometimes it is applicable, and yes, why not? You can do that. Do you have an experience of doing something like that? You mean, do you have of rating the generated data? We have, like what I can remember, we have, of course, the tasks of like moderation of ads, for example. Many of advertisements are generated automatically. So this is one of the examples of such cases. The increase of number of crowd workers makes evaluation of their performance on specific tasks less traceable. How you deal with that? It is not true, because we trace, we have such a thing, we call it skill, and the skill is assigned to every particular performer, and the skill is calculated basing on the performance of each particular performer. Of course, if the performer does not comes regularly and does not have a huge history of their tasks, it is more difficult to accurately estimate his or her skill and quality. But this would just decrease the level of trustworthiness which we give to this person. And that would mean that, for example, we would need to increase an overlap and ask somebody else to confirm his or her verdict. But anyway, we are tracing the quality of every particular performer. The SDK of big platforms is never flexible enough to develop the tasks you specifically need. Do you track what clients are doing to develop the better toolkits? Well, we are in the constant contact with our clients, and I would say that our API is now very rich, and but we're developing it. If you have any particular requirements, we would be happy to discuss it. And I really like your questions. I would be happy to continue some conversation with you later, because I see that you are deep into the topic. What are your plans to compete with Amazon Mechanical Turk? Well, if you have used both Amazon Mechanical Turk and Taloka, you would see that actually Taloka is much more developed a product, speaking about applications for machine learning. And we have a much richer set of tools for the quality control and anything like that. I would even say that some of the teams of the Amazon are using Taloka instead of Mechanical Turk, and they have tried it, and switched from the mechanical Turk towards Taloka. So this is the fact that speaks for itself. How do you fight with personal data leakage of people who produce the data? If I understand the question correctly, the major approach for fighting with any questions of data leakage is actually the responsibility of the requester. The major approach is to decompose the task to an extent where every single task does not contain any personal data. For example, you would never send a photo of the person's passport, right, to be transcribed by the crowd, because the photo of the passport is a huge amount of personal data. But if the requester on his or her side decomposes the photo of the passport towards the single letters and the single characters, every single character is not a piece of personal data. And then you send it decomposed to the millions of performers, and then you combine it back on your side. And that's how none of the personal data is being actually proceeded by the crowd. On the platform side, we have the moderation process and constant monitoring of such to make sure that such tasks are not being sent to the platform. And when we see some task, it actually goes in the contradiction with our user agreement, we immediately contact the requester and ask them to remove this task. If we speak about data privacy policies of the platform itself, we of course deal with all the correspondence with the legal base of the Switzerland, and we are also right now moving to keep all the store all the data in some international cloud services, but also there are approaches when the requester can just avoid storing any data on Taloka and just sending some pieces of data directly to the performers and receiving them back to make sure that none of the information is stored on the side of the platform. About the task complexity questions, thanks for your answer. Unfortunately, it seems to be the case for me. Scratching my head right now how to deal with that. Well, actually, we would be happy to discuss it with you and maybe help you solve your case, because really this is an interesting case and probably we can help you. Please contact me. You can see my email and myself and the team would be really happy to help you. What do you think of plugging some data labeling tools for certain part of Taloka's service? Could you please clarify this last question? I'm not sure that I understood it correctly. Integration with some common tools, like what tools? Tools for data, tools for, I don't know, image segmentation, right? Something like that. Other data labeling tools. Well, if you have in mind some of the tools that you would want us to implement, also please write me supervisory. Well, we will take a look. It's a good question.